Imagine a business that just closed a record-breaking month of sales. The revenue is booked, the growth looks incredible, and on paper, the company is highly profitable. Then, on Friday, they file for bankruptcy. Profit is recognized the moment a contract is signed, but cash flow is the actual physical movement of money into your bank account. You can't pay your employees with a signed contract. You need the actual cash. Ensuring you have enough cash to survive day to day is called working capital management. Think of your business as a bucket. Water represents cash inflows, while leaks represent outflows, like payroll, inventory, and debt. We can group these flows into 3 categories. First are operating activities. This is the core business cycle, the cash you collect from sales versus what you pay for the inventory and payroll needed to make those sales happen. Investing activities track cash used to buy or sell long-term assets, like equipment. Financing activities detail the cash moving between the company and its creditors, like taking out a loan or paying back debt. This slide shows the requirement for publicly traded companies to report their financial health using these 3 specific sections. It provides a standard historical record of where the company's money actually went. But just tracking past leaks isn't enough to prevent a bankruptcy. Managing a business requires predicting where those leaks will happen in the future, which is why static accounting is now being paired with advanced forecasting. Finance teams are moving beyond traditional spreadsheet-based forecasting. Because manual entry is vulnerable to human error and personal bias, machine learning models are being adopted to identify patterns in datasets that are too large and complex for a standard grid-based model to process. One specific solution is the Long Short-Term Memory Network, or LSTM. As this slide notes, LSTMs are a type of neural network that excels at processing sequential data, making them a powerful tool for finding patterns in financial time series. Standard networks often fail here because of the vanishing gradient problem. Think of it like a game of telephone. As information from a January sales spike passes through the network to predict December, the signal degrades. By the time it reaches the end of the line, the network has forgotten the context of the earlier data. LSTMs solve this with a memory cell. The network actively decides to store important long-term dependencies, like a recurring holiday trend, while filtering out the random day-to-day noise of the market. Because LSTMs can retain these long-term trends while ignoring chaotic fluctuations, they are uniquely equipped to handle the unpredictable reality of financial markets. Building this starts with data collection, gathering historical revenue and economic markers. Then, as seen here, we pre-process that data using a scaler to normalize variables, ensuring large revenue numbers and small interest rate percentages share the same mathematical scale. Next, we create sequences. We group a window of time, say 30 days, and set the model to predict the value for day 31. Then we shift the window forward by 1 day to predict day 32, creating a continuous chain of input-output pairs. Let's try it. If your target prediction day is December 1st and your model uses a 30-day sequence, pause the video and determine which specific dates would make up the input bracket. The correct input is November 1st through November 30th. Congratulations, you've just structured the input for a machine learning model. Finally, we train and evaluate. This slide outlines the process: splitting the data, using an optimizer like Atom to refine the model, and measuring performance using mean absolute error to ensure the forecasts are accurate before they go live. This pipeline is how raw, unpredictable financial history is transformed into a structured, predictive engine for the business. Even after deployment, the work continues. As this text explains, markets shift, so the model requires a continuous feedback loop. It pulls real-time data from ERP and CRM systems to retrain itself and adapt to new economic trends as they happen. There are trade-offs to consider. LSTMs are data-hungry and require significant computing power. They are also black boxes, meaning they provide a prediction without explaining the exact logic behind why they reached that specific number. If a company needs to see the specific factors driving a forecast, they may trade some complexity for models like random forests or XGBoost. These algorithms provide feature importance scores, making it easier for human analysts to interpret the results. To summarize, managing cash flow means tracking operating, investing, and financing activities to ensure liquidity. LSTMs solve the memory problems of older networks, allowing us to build a pipeline that collects, scales, and sequences data to predict those flows with high accuracy. Mastering the cash conversion cycle is no longer just an accounting task, it is a data science problem. Understanding the intersection of both is how companies maintain financial stability in a modern economy.